Hi, here's a little screencast, 3 things I've learned about lubridate as I was preparing for an Our Lady Sydney workshop. The first is how to use day, weekday, month, and year to pull date components and use them right within ggplot. The second is what to do when R thinks that your dates are characters and you actually want them to be dates. And then the third is how to deal with data where your dates are all in different formats and you need R to pull them into a consistent format. All right, so the first data set I'm going to work with are data from the New South Wales government about testing rates for COVID over the last few months. There was some concerns about a month ago that testing rates were really low. So I pulled this data from New South Wales Health, and we can use Glints to take a look at the data and see that it has the number of tests that were conducted each day, and miraculously recognizes the test date variable as a date. So once you have seeing that your dates are actually dates, you can use them within ggplot. So first we can take our test data and pipe it into ggplot and put test date on the x-axis and total tests on the y-axis. And if we use gonline, we can get a zigzaggy plot that looks like this. So it seems like testing rates were really low early in the pandemic, but increased a lot and have been really high since July, but maybe a dipping down towards September. It seems like there's some cyclical nature to this data as well. Maybe the testing rates are lower than in the weekend and higher during the week. So now that we've got has read our dates in as dates, we can use functions from lubridate to work with components of those dates right within ggplot. So let's look at tests across the pandemic by month. So we've got our test data. We're going to pipe it into ggplot, and on the x-axis, we're going to use the month function to pull the month from our test date variable and put that on the x-axis. And we're going to put the total tests on the y-axis, and this time use geoncol to get columns. So you can see that what it's done here is plot the month on the x-axis as a numeric variable. But we can use the handy thing in the month function where you can say label equals true to get it to use the actual labels for each month rather than the numeric values. I don't love the x-axis label that it has put on there, so I'm going to add labs and say x equals month and y equals total tests. And I want to color each of these months separately. So we can add after y, we can say we want to fill the bars with using, again, the month component of our test date variable, saying label equals true. Beautiful. Now, I don't necessarily want this legend because it's kind of superfluous, duplicated information. So there's a super useful function in the ggeasy package. ggeasy is a great package that allows you to easily do lots of things in ggplot that you usually Google every time. So this is easy remove legend. You can get rid of that legend pretty easily. So we can see that, yes, it is true that testing rates in September are really, really low. What about testing rates across the week? So what I'm going to do is copy this code template into the next chunk. And instead of taking tests by month, this time I want to look at testing rates across the week, so Monday through Sunday. So let's change this, and we're going to use, rather than on the x-axis putting the month component of test date, we're going to use the weekday component, and we're going to keep the label equals true so that it will use Monday, Tuesday, Wednesday, Thursday through Sunday rather than days 1, 2, 3, 4. And we want to keep the different colors for each weekday and label equals true. And we'll change our labels to call this weekday, total tests, and get rid of the legend. Let's see what that looks like. Nice. So you can see that it by default, it starts the week on Sunday, which I don't love. So what we can do is use the get option lubridate week start is 1 to make the default start of the week to be Monday rather than Sunday. So we do that within our weekday function here. So we can put it here. We want to say week underscore start equals get option lubridate dot week dot start. And we want to say start the week on the first day, that is Monday. And if we run that, you can see that we've got very high rates early in the week that decline over the course of the week. Okay, so what has happened to testing rates? What's going on with September? Why is September, these rates in September so low? So what I thought we could do is look at just the past couple of months to look at whether the testing rates have changed across the days of the month for the past few months. So let's take our tests data again and pipe it into, this time I want to filter the data so that we're only looking at test dates since July, right? So this will give us just the test dates since July, and then we'll pipe that into ggplot. And this time on the x-axis, I want to use the day function. So rather than weekday will give you Monday through Sunday, but the day function will give you the days of the month as in 1st through 31st. So the day, pull the day of our test date variable on the x-axis, and then again the total tests on the y-axis. And what we can do is we're going to do a column graph again. This time though, I want to fill the bars by the weekday. So the color of the bars will be according to the weekday component of the test date, and we'll include label equals true. And I also want to have the weekdays ordered Monday through Sunday. So we'll include week start equals get option lubridate dot week dot start and make it 1. All right, so then let's add a geom call. And what we want to do is have each plot separate by month. So if we use facet wrap, we can go facet wrap by, and we can have, again, use the month function. So to pull the month from the test date. And again, we want to use label equals true. All right, let's try that. Oops. That's right. There's a problem at this one. Oh, we need a closing bracket. Oops. Month of test date. Unexpected symbol. Month of test date label equals true. I just didn't select all the code. There we go. All right, so this legend is getting in our way. We can't even see the plot. So let's go easy, remove legend. And we can see that it's clear that we're missing a whole lot of data. So I downloaded this data at the end of September, but the reason why our previous by month plot looked so terrible, that the rates in September were so low, is that the data only goes up to the 11th of September. So there's a whole lot of missing data in this data set. It's certainly the case that in early September, the rates were lower than in August, but there's also a lot of missing data. So we can, as before, add labels. X equals day of the month, and Y equals total tests. Excellent. Oh, that's good. All right, so that's the first thing, how to use day, weekday, month, and you can use year in exactly the same way if you were looking at data across years. Functions from lubridate right within ggplot to make plotting by date much easier. So the second thing that is a really common problem with dates in R is that sometimes R doesn't think your dates are dates. So we were lucky with the COVID testing data, but most often in the real world, that doesn't happen to me. Most often in the real world, my date data isn't read into R as data. And so I was playing around with this using a Tidy Tuesday data set from a few weeks ago that had Taylor Swift and Beyonce sales and charts and lyrics. That was kind of interesting. So if we read in the Beyonce and Taylor Swift sales data, you can see here that this the released variable is the release date and its characters. So we can look at that in a different way. We can look at the class of any variable. So we look at the sales data and the variable, the class variable. You can see that it will tell us, oops, typing, it's released, not variable. So this is saying we want to look at the class of the released variable within the sales data frame. Oh, there we go. And it tells us that it's characters. We can also look at the format of the data by indexing the first item, the first observation in the sales data and the released, and it will show us that the format of that data is the month is represented as text, and the day, and then the year. So luckily, all of the date data in this released variable are in that month, day, year format. So we can use the month, day, year function from lubridate to convert what initially thinks as characters into date format. And there are similar ones for if your dates are in day, month, year, or year, month, day. So let's do that. We have the variable we want to convert is the released variable from the sales data frame, and we can say we want to convert the dates from month, day, year. And then if we do these again, now if we run class, it'll tell us that the class is date. Now if we look at the first observation, we now have data that is a consistent format and is year, month, day. All right, so now that we have data in that thinks are dates, we can plot sales by year and perhaps country to compare Beyonce's and Taylor's sales across their careers. And this data set only has both of Beyonce and Taylor for US and UK sales. So what we want to do is filter to pull just where country is either the US or the UK. And then we can pipe that into ggplot And on our x-axis, we want to plot the year that the album was released. So we use the year function from lubridate and say pull the year of the released variable. And we want to put sales on the y-axis, and I want to plot points connected by lines. So I want those points to be different for each country, and I want the lines to be connected for each country. So I need to have the color of the points be by country, and I need to group the points together by country. And so I'm going to add geom point and geom line. And I want to plot the sales separately for each artist. So I'll use facet wrap by artist. All right. Cool. All right. So it looks like back in the 2005, Taylor was very popular in the US as a country artist, but her popularity declined until she released this bump. The point that is a bump in her career was when she made her first foray into pop and released her 1989 album. So you can see that Beyonce's sales were initially higher, probably due to her fame in Destiny's Child. All right, so that's how to deal with characters and convert them into dates, and then to use the year function from lubridate within ggplot. So the third thing is what to do when your dates are in a million different formats. So sometimes you forget to restrict how your participants enter their dates and the data that you're collecting, and you end up with lots and lots of variability in how people enter their data. So to kind of play around with trying to work out when reads dates as dates and when it doesn't, I did a little Google survey to and asked people to enter their birthday 3 times into a Google form. The first of them, I just said, enter it however you like. The second, I gave them a little calendar widget to restrict how they entered it. And the third, I said, I want you to enter it in year, month, day format. And I wanted to see which of these would read into R. The free dates in that data set are a real problem. So here I'm reading in the difficult date data CSV and selecting just the free entry dates. And so if we run this and look at the top few, you can see that there's lots of variability in how people enter their dates. What do we do when we end up with dates that are in all of these different formats? Well, in reality, there are actually only 3 formats. And there is a function in lubridate called parse date time that does a really good job of guessing guessing what format the date is in and pulling it into a consistent format. So we can use that. I'm going to take my different difficult date data, and I'm going to use mutate to create a new column. So at the moment, we open this up, I've got a column called free dates where the dates are in all kinds of different formats. And so I want to create a new column called parsed free dates. And I'm going to use the parse date time function from lubridate and tell it that I want it to parse the free date column, and to use the formats, the 3 most common formats, which is year, month, day. Some of the dates are in year, month, day. Some of them are in month, day, year, and some of them are in day, month, year. Right? And if we run that, it'll tell us that object diff date not found. Oh, because the data frame here is called difficult dates. Let's try that again. All right, so you can see here that it has done a pretty good job of parsing these dates. And if we look at, that go away, it only makes a couple of mistakes. So if we look at the difficult date data, let's actually run that again and assign it to a new data frame. Whoops. Okay, so problem with mutate, one failed to parse. And I think this is just a warning. So if it's created this new data frame over here, it's just warning us that one of the dates failed to parse. So if we open this and have a look at it, you can see that there is one date down here where the person entered their birthday with the month and the date, but didn't give a year at all. So that one failed. But other than that, it has managed to parse the other 20. So there is one here where it makes a mistake, and this is this one here. So 6th of July 67, R has made that person be born in the year 2067, which is obviously not possible. But you'll notice that it manages to get other instances where there's just a 2-digit year right. So and particularly when there's a stand-in for the other digits in the date, it does okay. So it's a pretty clever function, and in this case, it just failed on one that didn't have a year and made a mistake on one that was a 2-digit year. But other than that, it's pretty clever. So if you accidentally forget to restrict the way that your participants enter their dates, don't despair, take a breath, and try the parse date time function. All right, there's 3 things about lubridate.